Hello viewers, welcome back to another episode, and in this episode I want to talk about my VAX 4300, or essentially it's VAXserver 4300. This is the biggest VAX in my collection. Last time I showed you that machine over there, my VAXstation 4000 VLC, which is the smallest VAX in my collection, also smallest VAX ever built, and now I want to show you that machine. First, I want to lift it up on the table, but it's quite heavy, weighs about 68 kilogram or about 150 pound, so I'm not able to lift it on the table alone. Therefore, I will leave it on the ground. And in that video, I want to show the machine from the inside, all the connections, and later on the boot process. You've seen this machine in some of my previous videos, but I've decided to make a separate video about it because I've never introduced into that machine, because when I filmed my first video, this machine was broken and now it's working. So I think now a separate video on that machine is necessary. The price of that machine was 150,000 Deutschmark, or about 95,000 US dollar in 1990 when that machine was released. It was also the first machine of the VAX 4000 series that was released. And the price is for the server version, because you can see here, this is a VAXserver 4300, so it's a non-time sharing machine. There was also a machine VAX 4300, which was the time-sharing machine, and that costs about 220,000 Deutschmark, or about 135,000 US dollar. And a viewer in the last video commented that there was a discount on the prices. That's true, but I didn't find any information about the discounts, so I can tell you only the list prices from the year 1990. So now I will open the machine and explain all the connections, and after then I will disassemble some parts and we can have a look at some parts of that machine. Okay, let's open it. There's a key. It's made from anti-static plastic. I've only this one piece of key, but you can not have used the key. You can also use your hands to open it, but you can open it to the top. So you can only open the top one, and into the lower position you can open the whole machine. But it's not very secure. It's only, I don't know, to hold the door in place or something like that. Okay, there are two parts on the machine. Here on the top are the discs, and on the lower side here on the left are the Q bus for the extension cards. Now here's the processor and here's the power supply, and on the down here are the vans for the machine. In that machine I have 4 discs. The two left ones are RF74 with 3.5 gigabyte each. There is an RF72, is 1 gigabyte, and this is an RF31, and I think it's 380 something megabyte. And you have different things here on the plate for the disk. So here this is the ID. The disk's technology is DSSI. It looks a bit like a SCSI, but it's a DEC proprietary system. And this is the disk ID. You have IDs from 0 to 7, and this is disk ID 2, 3, here, 1, and 0 over there. And also the controller has an ID. So the system is a bit like a SCSI from its concept. Each disk has a forward light and 2 buttons. This button is the run button. So if you click the button, the machine is, the disk is available for the system, and with this button you can set the disk to read only, so it's the write protect button for each machine. These buttons are quite fragile. I have a fifth of these covers, but with broken buttons, so I think come with the age of the buttons that they will break someday. Here on the right are 2 separate buttons. This is the hold button. You can hold the processor, and this is the restart button. It's like a reset button on a standard computer, so the machine will restart if you push that button. Here is the power supply. I don't want to talk a lot about the power supply because I have made 3 separate videos about the power supply and the repair of the power supply, because that was the broken part of that machine. So this is 850 watt power supply, but I will leave the power supply there. This board here, behind this cover, are the memory and the CPU. I will take it out later so we can have a look at the board and the memory. And here are several connections. Here you can set the baud rate for the terminal. The terminal will be connected here. This is the terminal for the operator of the machine. Here is a small digit. I can see some digits which for processor code. So if the processor generates some errors or how's the state while booting, you can see it here. These are the two IDs for the DSSI controllers. This machine has two DSSI controllers inside. The one controller has the ID 6 at the moment, and one controller has the ID 7. 6 is the controller with these two connectors, so you can replace the machine also in the middle, not at the end. And this is the connector for the other DSSI controller, which goes through all the disks here, and then the connector is over there, but there's only one end. So for that DSSI controller, you have to place the machine at the end of the bus. Then here is the Ethernet connection. This is AOI, and the BNC is SYN Ethernet, and here you can switch between both connectors. So you can use only one of these two connectors at the time. On the left are is a bus called QBus. There's one card in this, is KZQSA, and this is a SCSI card. But you can put into up to 7 QBus cards into that machine until you reach the end of the limit of the power supply. Then there are tables where you can see how much each card needs, and when the power supply limit is reached, then you cannot put more cards into that machine. Yeah, so now I will open it and will also take out the SCSI controller, and I will show you all of the cards in detail. Okay, now you can see several parts here. If you take out of the machine, here these are the vents, two 24-volt vents which are located down on the machine. This is the front cover for the CPU. I've described the all the connections, and at the back are the connections to the CPU board, to the processor board. And over there the battery was located, but I took out the battery very early, so the battery does not leak, and this board is perfectly in perfect shape, so there was no corrosion based by the battery. And over there, as an example, I put out the RF31 hard drive. It's connected with this cable here to the front cover. And the other 3 hard drives have a double size of this. So this drive is only half size, and it's connected to the backplane via this connector over here. Now let's have a look at the boards. Let's start with these 3 boards. Here on the left is the SCSI controller. It's just a normal SCSI controller. It's just some jumpers here and nothing on the back. 2 connectors. It's quite simple design. More interestingly, these 2 boards here, these are the RAM modules. I think on the right is the 32 megabyte RAM module, and on the left is the 64 megabyte RAM module. You can see it if you turn it around. The 64 megabyte module has also chips on the downside, where the 32 megabyte module do not have these chips. So the difference is one has two-sided, or is two-sided and one is one-sided. It's the difference between the two. The chips are made from Siemens, German chips, but the controllers are made from DEC. So these are original DEC RAM modules. But you can see from that point of view, from this side, they look quite equal. Only the other side is the difference. Now, this is the interesting board of that machine. This is the KA670 processing unit. And it consists of the Rigel architecture. The Rigel architecture was first introduced in 1989 with the VAX 4000 model 400, and it can also consist of a vector processor. But the VAX 4300 do not have this vector processing unit. You can find in some of the VAX 6000 series. In difference to the processor of the VAX 4000 VLC you've seen in my last videos, this is not a single chip. The CPU is divided on multiple chips, basically here on the left side. The base chip is that one, where's the ALU located. This is a DC 520. It has a clock of 143 megahertz. but on top here there is a separated floating point unit for that processor. Then here is the clock located. This is the cache, it's a 2-level cache, and this is the memory controller. So this is the CPU. On the right side are several chips for communication. This is the Q-bus controller, and this is one of the 2 DSSI controllers. The other one is here, and this is the Ethernet controller. And over here the ROM is located. On top here, this is the connector for the front cover, and this is the connector for the backplane. Okay, now I will put everything back together, and after that I will show you the booting process and do some comments on the booting process and what you can see and how VMS is booting on that machine. Okay, now it's working again. It took me over a day to find out what was the issue with the machine. First I thought I violated the golden rule, never touch a running system, but the issue wasn't caused by my removing of the board or something like that. First I thought I've damaged the board and I need a new CPU board, or I've damaged the bus connection or something like that, but that didn't was the case. Behind that disc here over there is a small board, and this board is called V-term dual regulator module. And I've looked at that board, and the capacitors of that board were blown up, and therefore the discs won't start. I do not really know what is the purpose of that board, but I think it's to control the power at the start up of the hard drive, so that the PSU do not have to provide so much power when the hard drive starts all at the same time. So therefore I have repaired that board, and after that everything worked well. So then let's start the machine, and I will record the console output with the laptop over here, so I can do some comments on the boot up process. So now we'll turn on the machine. And first I will ask about the language of the machine, because the battery is missing. I will ask the language question every time I will boot up the machine. And now the system performs some system tests. I will do now a live comment about the boot up process. It takes about 10 minutes, and I won't fast forward any parts, so therefore maybe it can be a bit boring, because sometimes nothing happens. So now you can hear the disks coming up, you can see the computer in the top right corner, and you can hear the disk starting up process. I have to disconnect the VAX 4200, because with the connected VAX 4200 the machine won't start, or won't detect the devices. Maybe the issue with the V-term regulator board have break something in the other machine. Therefore the machine starts stand alone at the moment, and the DSSI cable is not connected in the top, in the bottom left corner. So now we see the available devices, all 4 of them, and at the end it takes a few seconds. We'll see also the Ethernet controller as an available device, because we can start that machine also as satellite if we want. So now I have to enter the disk where the installation of VMS is located, and this is DIA3. And after a while we can see the OpenVMS startup procedure. So we can see starting OpenVMS for VAX version 6.1. You can hear the disk access sometimes. So first we will ask date and time, and the current date is the 20th of May 2024. And time of recording is 31 minutes past 3 p.m. And then it tries to join a VAX cluster, and because there is no running VAX cluster, the machine initiates a new VAX cluster, and also it starts the MSCP disk server, because that machine is the disk and the boot server. And then it tries to access a quorum disk. And that process takes a while. And I think when I understand this quorum scheme in the cluster correctly, the machine will stop the processing at this point until enough nodes, enough voting members are there, because there are some cluster members have a vote, and you need a minimum number of votes in a cluster. But in this cluster, because it's a dual host system, the cluster needs only 2 votes, and 1 vote is the quorum disk and 1 vote is the server. And therefore the cluster has enough votes to start with this single machine. If I would add a third machine into that, I have to add a vote to the whole voting process, and then I think the cluster will start only when 2 machines are running. I hope I've described it correct. Maybe there are some VMS experts and cluster experts who've done it with a machine in a real environment. It's only what I've read about the voting system. So now the machine tries to start the page file and swap file. The problem is, we'll see later, there was a separated page and swapping disk in the original configuration, because there were 8 hard drives in the original configuration, and one of them was for paging and swapping, and this hard drive is missing. So the whole machine starts without a page file and a swap file. I think we will see it later, the machine creates a temporary page and swap file on the system disk. You can also there see the set CPU ID exe, which is not found on that machine as well, which changed the CPU ID of my VAX 4200. So there's a German message, because the system can't find the disk $1 DII4, and now it starts with not page file and not swap file. But now we can see there are some files called not page file this and not swap file this. I think these are temporary files. So after that, it goes very quickly. We can see a lot of terminated licenses, and also some security servers are starting, and the shadow server are starting. And after that, the network is starting. First it starts StackNet, then LAT for terminal servers. And after that, UCX or TCP/IP with all the different TCP/IP servers that are running on the system. For example, Telnet, we see some errors because the NFS server is not working properly, but I do not use NFS at the moment. And after that, it sets some logical values, and after that logical names, and after that it will start Oracle. I think it will start Oracle. Oh no, first it looks the disks, and you can see there are some disks missing. DIA5 is missing and DIA10 are missing, but these two devices were volume shed members of the other two RF74 devices in that device. So the volume shadow set is kind of software RAID 1 on VMS. So the both data disks, the big ones, were mirrored, and one of the members are missing, but the server is starting without that disks, and after that you can see it's starting Oracle on that machine. So, and now the machine is booted, and you can see the smashing, and I can log in with the system account, system and password, and now the machine runs. We can see the last login 9 days ago, and that is the end of that video, and I hope you will find that interesting as well, and you can leave comments below, and maybe I will see you in the next episode, and thanks for watching.